The long solution of differentiating an equation to find the slope follows a four-step algorithm. Learn how it goes here in differential calculus. The first example has the equation y is equal to 3x squared minus 2x, where we are to look for the slope at point 28. The first step is to replace all variables with a binomial having a delta. Since there are only variables x and y in the equation, we have y plus delta y and x plus delta x, making the equation y plus delta y is equal to 3 times the square of x plus delta x minus twice of x plus delta x. The next move is to expand the first term with the square and distribute 2 in the second term. So we arrive at 3 times the quantity of x squared plus 2x delta x plus delta x squared minus 2x minus twice of delta x. Continue by again distributing 3 to take out the parentheses, giving the following equation. The second step is to isolate delta y, and that is by transposing y to the other end of the equation. Also remember that from the premise, y is equal to 3x squared minus 2x. So we still have a simplified variable of x in the right side of the equation. After doing so, we can simplify the equation further by eliminating 3x squared and 2x, thereby having delta y is equal to 6x delta x plus 3 times delta x squared minus 2 times delta x. The third step is to divide everything by delta x, which simplifies the equation further into 6x plus 3 delta x minus 2. Then the equation is ready for the last step, which is to find for its limit as delta x approaches 0. And that entails that the middle term 3 delta x turns out as 0. Finally, the derivative of the equation, which is also termed as y prime, is 6x minus 2. With the point of concern given as 2, 8, we can plug 2 into x, making the equation y prime is 6 times 2 minus 2, giving the slope as 10. The second example has the equation y is equal to 7 minus 3 all over x to the fourth power, and we need to figure out the slope at 1, 0. Again, the first step is to replace y with y plus delta y and the x's with x plus delta x. Now note that the denominator x plus delta x raised to the fourth power can be expanded easily using the Pascal's triangle. If we check the progress, we can identify the coefficients for the binomials with the fourth power, so the last term's denominator will expand out with the coefficients 1, 4, 6, 4, and 1. That's the expanded equation ending step 1. So now, we start with the second step, which is to isolate delta y. And that is done by simply transposing y to the other side of the equation. And since y is equal to 7 minus 3 all upon x to the fourth power, we can eliminate 7, leaving the equation as two terms, one with the long denominator and the other being 3 all over x to the fourth power. To avoid having too many terms, we take the LCD, which is just the two denominators multiplied together. Then manipulate the numerator to come up with the equivalent fractions. With the long equation, we still need to simplify to make it somehow shorter, and that is by taking away the parentheses. That's by distributing the terms outside the quantities. The equation turns out to be even longer, but then we can now eliminate negative 3x to the fourth power with its positive counterpart, ending up with a somehow shorter equation. Now with step 3, we divide everything by delta x, but since the equation already has a denominator, and to make the presentation simple, we just multiply the equation by 1 all over delta x. This step can actually cancel many deltas from the numerator, making the equation of delta y all over delta x as 12x cubed plus 18x squared times delta x plus 12x delta x squared plus 3 times delta x cubed all upon the quantity of x to the 8th power plus 4 times x to the 7th power multiplied by delta x plus 6 times x to the 6th power times delta x squared plus 4 times x to the 5th power times delta x cubed and x to the 4th power delta x to the 4th power. This is the simplest form of the equation ending step 3. Moving on to the last step, which is finding the limit of the equation as delta x approaches 0. Note that the delta x's turn out as 0, completely eliminating so many terms. Now, the long equation ended up with only 12x cubed all over x to the 8th power. So simplify exponents to have delta y all upon delta x, known as y prime, as 12 all over x to the power of 5. With the coordinates of the point as 1 and 0, plug 1 into the x of the equation to come up with the slope as 12.